So let us see equations of a trajectory. In this lesson, we have seen the introduction, the projection from the level ground. Now let us see these ones here. Now, recall that this was a diagram from the level ground of projection where R is going to be our distance covered by this particle before it comes back to the level ground. Then S is going to be the maximum height reached by that particle. Then the time to cover this is going to be T. Recall the vertical motion, these were the things we had from the previous lesson. Even the horizontal motions, these were the things we had. And so there. So now at maximum height, this maximum height at A, this A here, always our Vy at A, we set the maximum height, always the velocity is 0. So when you substitute now in here, because we are dealing in a vertical displacement, so that to get the vertical, I mean the height. So when you put here 0 and you make the subject, we take this side because this will be 0. So when you divide by D, get this. So this is the time taken for a particle to reach the maximum height. Given we had like this. So now the whole of this, remember, is equal to 0. Okay, then the maximum height means if we have the time it takes us to reach the maximum height, then we can get that height. How do you get that height? Remember, this is the displacement from here, the y, this is the height, the displacement in the vertical motion. So meaning, if we have the time it takes us to reach the maximum height, it means that now we substitute here. Where they start, we substitute those things. And then simplifying, so when we get this is squared, then sine squared over d. When you square this, you get this squared, sine squared over this squared. So this squared, the one we cancel with this, that's why you have this. Now you see that from here, we come to this, then when you factorize out, this is common. When you factorize it from here, we have 1. When you factorize this and this d, we remain with a half. But 1 minus a half, the whole of this is going to give us a half. So when you get now this a half times this will just come to this, and that's why we have our vertical as 2d, like that. When we multiply this times this, that's when we shall get our maximum height as that 2d. Okay, so from there now, we come to the time of flight. Time of flight is the time taken for a projectile to return to the level of projection. At the level of projection, displacement is 0. Now, if the particle moves here, up to here, we say the displacement is 0 because it has gone from here up to here, it has come back. So the displacement is 0 in simple terms. Okay, so now from there, if displacement is 0, it means that our displacement here is going to be 0. And then when we substitute here, the displacement in the vertical component is going to be 0. So that's why we are substituting it here. But then the time of the flight. So this time of the flight is t, capital T. So when I have it there, then you start this capital T. When you factorize out t from there, we have 0. Then this all equal to 0. So either this is 0 or this is 0. But it's 0 when the particle is at this state. It has not moved. So that's when it is 0. Then when we make it to the subject here, we get this. And that will be our time of the flight. So that is the explanation there. Range. Range is a horizontal displacement covered by a particle returned to the level ground. Now, when the particle is from here, then comes back here. The distance it has covered on the displacement is what we call the range, which is going to be R. But not for now, this one is already with the horizontal component. That's why from this here, then we need now our x is going to be the distance, the whole of this distance from here to here. Let us call it r. Now, to cover, we said that to cover this distance, you need the time t. The time for this particle to come from here up to here. So now at that t, that's when I'm substituting where there is x, now it's going to be my r. Then this t is going to be the time for that flight. When I substitute them here and I put now this here, when this multiplies this, I get u squared 2 sine theta cos theta over this. But know that the whole of this is a double angle formula for sine this one again. So this one is sine to theta, the down angle formula. In a tree, putting it there, life becomes very nice. Then, that's how we get the distance from here up to here. Okay, now for the speed of a projection, R varies with the angle of projection. The maximum range is, when we want to get the maximum range, how this particle is going to be, we need to get the maximum of this, because the angle is varying. It starts varying with the angle of projection. That's why this one we don't mind the name. So it's going to vary. Because it's varying with this, then we need to get these are constants. So then this one is going to be the maximum. So to maximize this, you know that, remember in the tree, when we have a diagram like this, I think remember how we are drawing the sine curve. So this is our sine curve there. Same always, it's going to attain its maximum at 1, then its minimum at -1. I think remember how we are drawing those things. So in terms, if you reach the maximum, like this, and it reaches the maximum, it goes down. Then it reaches the minimum, then it comes like this. So this is where we have our maximum always. The max of sine. That's why it's always equal to 1. So when you get to start the angle, it means that to get the maximum, it means that you need to project that particle at an angle of 45. So to get the maximum distance, then this should be 45. So then when we put in, because we said this should be to maximize this, because this R, we said it varies with the angle of projection. So max this is equal to 1. So where there is this, we put a 1. Then this will be the maximum distance covered by the projectile. So after knowing that now, members, we are going to see now examples. What happens in those examples? So see you there. Don't ask yourself why I did this. Now, you can get this by using this formula, the third equation of motion. So, when you put here in this, you spread this, and then you put this, and then you make y the subject, I mean h the subject, you are going to come up with that something. Because we say that at maximum height this is 0. So instead when we square this, we shall be getting this. Then when you divide through by 2b, you will have reached the answer earlier. So either use this or use this approach, it's okay. Okay, as you see here, then when you simplify this, take this side, divide through by 2, you get the same thing, right?